Good morning, one and all. I'm Padmapriya, Assistant Professor in CSE Department of RMD Engineering College. Today, we are going to see the topic Spread Spectrum, DSSS and FHSS under the subject CS8601 Mobile Computing. What is spread spectrum? Spread spectrum means it is used to spread the user data into a broadband signal so that we can reduce the interference while during the transmission. So for this, we are having two mechanisms. First one is direct sequence spread spectrum, and the second one is frequency hopping spread spectrum. Coming to the topic, direct sequence spread spectrum, DSSS. Here, the user data is going to be XORed with a chipping sequence, which is going to be a pseudo-random number, which is being generated using the Banker's algorithm. Now, this XORed data, the resulted data, is going to be a broadband data. That is the user data which is being spreaded into a broadband signal. And this data is going to be sent to the sender, to the receiver. By doing this, what are the advantages means? First one, it will reduce the frequency selective fading. And mostly in cellular networks, the base stations are having very few frequencies which has to be repeatedly used. So by applying this algorithm, we will be able to make these base stations can use the same frequency range. And also, several base stations can detect and recover the signal without any problem. And the handovers are very much smooth, soft handovers. The disadvantages are it needed precise power control. Here, for example, I have taken user data 0 and 1. Now, this user data is going to be XORed with a chipping sequence, which is being given here 0, 1, 1, 0, 1, 0, 1, 0, 1, 1, 0, 1, 0, 1. Now, by doing the XOR with this chipping sequence and the user data 0, 1, we will be getting the resultant signal that is 0, 1, 1, 0, 1, 0, 1, 1, 0, 0, 1, 0, 1, 0. Where TB is going to be the bit period, that is the time taken for one bit, and TC is a chip period, that is time taken for one particular chip in the chipping, one particular bit in the chipping sequence. This is the block diagram for the direct sequence spread spectrum. First, in the transmitter side, the user data is going to be XORed with the chipping sequence. Now, this XORed data is the spread spectrum signal, which is going to be sent to the receiver, whereas this is the digital data, so that we are going to convert that into the analog signal by using the modulator, where we are going to give a radio carrier, which is going to be convert the signal into the analog signal, and this signal is going to be transmitted to the receiver. And on the receiver side, the received signal is going to be demodulated, where the analog signal is going to be converted to the digital signal. And this digital signal is going to be applied to the correlator. So in correlator, first, we will be filtering all the data because there will be some noise interferences and broadband interferences. So these interferences and all is unavoidable. So these interferences and all is going to be filtered using low pass filter, and then it is going to be XORed with the same chipping sequence which is used in the transmitter side. And this product is going to be integrated, and from this data, the sample sums is going to be taken, and the data is going to be checked with the sampled sums, and the original data is going to be recovered in the receiver side. The next topic is frequency hopping spread spectrum. This is another way of doing spreading the data. Here, instead of digital data, we are going to take care of the carrier frequency. Here, the sequence of frequency changes, which is going to be determined by a pseudo-random number sequence. Here, we are going to have two patterns, fast hopping and slow hopping. In fast hopping, several frequencies will use one user bit, and in slow hopping, several user bits will use one frequency. The advantages of FHSS is frequency selective fading and interferences are limited to a very short period of time. And the implementation is also very simple, and it also is only a small portion of the frequency spectrum at any time. And the disadvantages are it is not that robust as the DSSS, and it is also very simple to detect. So this is the frequency hopping spread spectrum. So here in the example, I have taken the data 01011. So here again, the TB is going to be the time taken for 1 bit period, 1 bit. And the second diagram is slow hopping and the third one is the fast hopping. So as I told you, in slow hopping, several bits are going to be transmitted using one frequency. So the first three frequencies 0, 1 and 0 is going to be transmitted using the frequency F2. So you can see in near the F2, you have seen an under the line which is below the level, that is for 0, and above level is for 1 and below level is for the third bit 0. And the next 3 bits are going to be transmitted using the another one frequency, that is F3. 1 and 1 is going to be taken through the F3. So this is the slow hopping, and where is the period is going to be 3 bits per hop. Coming to the fast hopping, here 1 bit is going to be transmitted using several frequencies. That is, in this example, I have taken 3 frequencies are going to be taken for transferring 1 bit. So for the first bit 0, it is going to be transmitted using the range the first F1, F3 and F2. Now the second bit 1 is going to be transmitted using F3, F1 and F2. Third bit using F3, F2 and F3. Fourth bit F1, F2 and F1. Fifth bit F3, F1 and F2. So by using this fast hopping, we will be able to transmit each and every bit using several frequencies. So by doing this data is going to be spreaded. This is the block diagram of FHSS, where the user data is going to be applied to the modulator and it is going to be converted to the broadband signal. And this modulator is going to apply this frequency synthesizer. The frequency synthesizer is nothing but the hopping sequence. So according to the hopping sequence, these signals are going to be spreaded and this spreaded data is going to be sent to the receiver. Now the receiver, once the signal is being received, it will be demodulating the data by applying the same hopping sequence through the frequency synthesizer. And this narrowband signal is going to be again demodulated and the original data is going to be sent to the receiver. So that is with the spread spectrum and DSSS and FHSS. Thank you.